Alright, in this video tutorial, we're going to work with the Cleveland heart disease dataset that we downloaded last time from the data.world website. I think we saved it in our Edge drive from this PC, Edge drive, Biostat lab, and that's the data that we're gonna work. Heart disease for more than 300 people, 300 patients, and we had some characteristic recorded for each patient. Okay, so first of all, let's open our R Studio from academic software, R Studio. The first step is to, in R script editor, is to create a comment that helps us for the next time that when we open our R, we know that what we're gonna do, what this code does for us. Okay, so this code is to practice making graphs for categorical and quantitative variables. Okay, so the first step is to read the data set, read the CSV file, right? So let me create the comment, read the data. So we use for the CSV file, if you remember, we use read.csv command. And so it has, first we have to read the file and then the header, if there is header, so we have to set the header to true. So we used file.choose, if you remember, file.choose. File.choose allows user to select the CSV file. Okay, and also we need to set the header to true, to treat the first row as the names. Okay, so the next step is to store this in an object, for example, with the name of any appropriate name that you prefer. I just use data. Okay, and so when I click run, put my cursor of mouse in this code and then click run, and I have to select the CSV file. Alright, so we have 303 observations or patients and 9 variables. So let's check the first few lines using head command. Okay, so we use head of the data and then click run. So you can see for the first few lines we have line 1 to 6 for all of the variables and also the rest of the variables. You can also check the last few lines using the tail command, right? Tail data. And also let's have a summary of data. So summary of variables. Okay, we use summary command and the name of data set, which is data, and then click run. So recall for quantitative variable, R returns minimum, maximum, mean, first quartile, right? Minimum, maximum, mean, first quartile, median, third quartile. So these are for the quantitative variables, right? Such as age, resting blood pressure, chest. So this is not a quantitative, this is actually a categorical variable, but have to change it if you want to treat this as a categorical variable. But for categorical variable, it shows us the frequency table. Okay, so the values that we have, for example, for sex, female and male, and then number of the people in each level of the categorical variable. That's a summary of variables. So let's start with categorical variable. Okay, so I create this categorical variables. For the categorical variable, the first important plot or graph is bar plot. Okay, is used for categorical variables, and it shows frequency, and also it can show the percentage or relative frequency or proportion for each category. So first of all, we need to, if you remember from the class, we need to first to generate the frequency table. And in R, to generate the frequency table, we use table command. Okay, so for example, what I'm gonna do is I'm going to select one of these categorical variable. For example, heart disease. This is a categorical variable. Okay, and then I'm going to generate the frequency table for it. Okay, so what can I do is from data I use $, and then I select heart disease. Okay, and the reason I do this because I don't want to use $, a lot in writing the code. So I save this in an object with the name of, I don't know, heart.presApps. Okay, and after that I can now generate a table for it. Okay, the frequency table for it using the table command. Okay, so table, the input variable will be our heart.presApps variable, which is categorical variable, and then I will save it in table 1. Okay, so let's see the table 1. So if I select this one, so heart.presApps, so first I have to run this code because the order is important, right? So I have to run this code. So R now knows heart.presApps, and after that I run this code, it creates a table 1, and now I can see the table 1. Okay, that's the frequency table. So I make a comment here that this is frequency table for heart disease. Okay, so the next step after creating the frequency table for heart disease presApps is to use Barplot command. So remember, you shouldn't use a space between bar and plot. Okay, so it's very simple, just use Barplot, and the input for the Barplot should be our frequency table. Okay, which is table 1. Table 1. And if you click run, so now you can see we have bar plots of the heart disease, right? Heart disease presApps, which is also a categorical variable. It has 2 levels, absence or presence, and for each one we have frequency for the people that didn't have heart disease and for the people who had heart disease. Okay, so that's how we can generate bar plot. But let's make this a little bit nicer. So what we can do is first of all, let's add a title. So we use main argument to add a title. For example, Barplot of heart disease. Okay, now if you click run, so it will add a title. And also let's add a label for x axis. For example, the heart disease, presence or absence of heart disease. So we can add a label to x-axis using xlab and heart disease. So the next thing is for the y-axis, I think it's better because the y-axis shows count or frequency, right? So let's add a label for y-axis using ylab command and then count. So you can see we have count in the y-axis or vertical axis, and also we can limit the y-axis, so the values can run from 0 to 200, okay, instead of 150 because it doesn't contain the rest of the values. So I can limit the y-axis using ylim, y limit, and I'm gonna limit this into between 0 and 200. More than one value, so I use C command, and 0 and 200. The next thing is we can change the color of this using col command, and I'm going to have a color for absence and a color for presence, so it should be more than two numbers or two values or two characters, because this one also can be numbers. So I use blue for the first one and red for the second one. Okay, and finally I can add a box around this bar plot. Okay, so out of the bar plot box, open and close the parentheses, and then run, so it creates a box around it. So that's how we can generate bar plot for categorical variable, and each of these bars shows the frequency or count for that level, okay, presence or absence of this categorical variable. Let's create a comment for this. So bar plot or generating bar plot. As you know, bar plot can also be used for the relative frequency or proportion or percentage. Okay, so here if I so I have table 1, right, which was number of people with heart disease for each category. So if I divide this by the total number of values, which is 303, so we will have percentage for each category, right? So if I divide the table 1 by 303, we will have percentage for each category. So I can use this for generating the relative frequency bar plot. Okay, again, let's create the relative frequency table. Relative frequency table, and so I'm gonna use table 1 divided by 303. Okay, and then I save it in another table because it's different. In table 2, now I can here see the table 2. Okay, so table 2 is created here, and then here I can see the table 2, which is based on the percentage. Now it's very easy. Again, I can create the bar plot based on the percentage or relative frequency. Okay, so I can create the bar plot, and it is based on the table 2 this time. Okay, now if I click run, so the values are percentage, okay, in the y-axis, the proportion. Again, you can make it look better. We can also copy the values, for example, from the table 1 and then change it. So this one. So main is bar plot of relative frequency of heart disease, and XLAB is heart disease, YLAB is not count, okay, it's percentage or proportion, and YLIM, so it is not between 0 and 200, it is between 0 and maybe 1 or half. Let me select 1, and the color blue and red, and create a box. So let me run this. So bar plot, so percentage heart disease, bar plot of relative frequency, and create a box around it. You can also add a legend to the bar plot. So using legend.text argument, so if I any places, for example here I use legend.text and I set this to true. Okay, goes to true, and if I click run, I can see that the legend will be added. So the blue shows absence, the red shows presence of the heart disease. This one is frequency or count, and if I copy this, this is generating bar plot for relative frequency or percentage. So in summary, for creating the bar plot, first we need to create the frequency table or relative frequency table using table command, and then create the bar plot using the bar plot command. And the input argument for the bar plot should be your frequency table or relative frequency table. And also sometimes you may want to have horizontal bar plots, and you can create it if you just if we look at the help of the bar plot. I think horiz HORIZ argument, if we set this to, so the default value is false, but if we set this to true, we can generate the horizontal bar plot. Okay, so if I add this, and make this true, okay, so I can generate the horizontal bar plot, but it's out of the, so you can generate the horizontal bar plot using this argument by adding this argument HORIZ and set this to true. Okay, the next categorical variable that we're gonna talk about is pie chart. Okay, so let me create a command to make it clear. And to create a pie chart, we use pie command. Okay, so it's very easy. And the input value for the pie command is the table. It can be frequency table or relative frequency table. Okay, so let me, because we already have the frequency table, I use it here, table 1, and then I create the pie chart. Okay, so but this one shows the presence or absence. Okay, and how about the pie chart of table 2? Again, is similar to the table number 1. Okay, pie chart of the frequency and relative frequency, there are no difference between them. And you can also add a title to this pie chart. For example, I can add main argument. Using main argument, I can add pie chart of heart disease. So it's presence of heart disease or absence of heart disease. Okay, and you can change the color of it and also the legend and other characteristics. But as pie charts are not recommended in literature, I leave it to yourself. If you would like to learn more about it, you can just search it here, help, and then type pie. Okay, and then you can read the argument, what you can change to the, you can change the angles, you can change the color, density, and so edges, radius, so you can change this using this argument. So now let's move on to talk about situations where we want to compare two categorical data. For example, we want to compare sex, male and female, and also heart disease presence or absence. Both of them are categorical variables, and we want to compare them. Okay, in this case, first we have to create a 2x2 table, also known as contingency table. So again, we use so let me create comment that this is for two categorical variables. So again, we use table command, and it's very similar to the one categorical variable, but instead of having just one categorical variable inside the parentheses, we will have two categorical variable. Okay, so the first categorical variable was within the data. Let me select this one. Sex was a categorical variable, and also the other one, which was heart disease. Okay, so now I'm going to save this in an object with the name of table3. Okay, run. So if I want to see that, table3. So here is the contingency table, a 2x2 table. I can see that among the people who didn't have heart disease, 72 of them were female, 92 of them were male. So these are controls. And among people who had heart disease or cases, we have 25 female and 114 male. Okay, so I'm going to create the bar plot, but in this time it's for two categorical variables. So there are no difference between the bar plot for one categorical variable and two categorical variable in terms of using the command. So again, that command is bar plot, and then the input will be your table, but this time is table3. And if you click run, it will create a command that among the people who had heart disease, we will have, most of them have, I think they are female, so we need to add the legend. First of all, let's set the legend.text to true. Okay, run. So these are female, these are male. You can also change the color, col command, so more than two values we use blue and red, or maybe green and red. And also you can change the other things. Okay, you can change the main, you can change the lim, y limits, and also we can make some other changes in this bar plot. Okay, create a box around it and so forth. This bar plot is also called a stacked bar plot. Okay, and so you can compare male and female directly for the cases and also for the controls. So that's the stacked bar plot. This is how we can create. So this is stacked bar plot. Okay, so the next thing is if you add a new argument, for example, to this stacked bar plot, you can create side-by-side bar plot. Okay, so if I set the beside argument to true, okay, they will be side-by-side bar plot. Again, you can add argument like lim, box around the bar plot, and so forth. So I leave it to yourself. Now let's move on to talk about the quantitative variables. Okay, so here I create quantitative variables. So far we talked about the categorical variable, but now we're going to talk about the quantitative variable. The most common plot when we have just one quantitative variable is histogram. Okay, and histogram is very similar to the bar plot and also can show frequency or percentage for each bins. So the difference between bar plot and histogram is that for bar plot, each bar shows a level in categorical variable, but in histogram, each bar represents a quantitative variable. And also in the bar plot, there is a gap between the levels, but in the histogram there are no gaps between the levels. So how we can create the histogram? Create histogram. So we use hist command in R to create a histogram, and what we're gonna do is we're gonna create the histogram for, you have to select the category, a quantitative variable, right? So let me see which one. So age is a quantitative variable. I'm going to create the histogram for age. Okay, so first of all, let me extract age. So from data, I use $sign to extract age, and I save it in variable with the name of age. Okay, and then click run, and then I'm gonna create a histogram for age, right? This is a histogram of age. You can see there are no gaps between the bars, and also the bars are automatically creates this number of the break. Okay, 1 2 3 4 5 6 7 8 9 10. We have the values of the age are almost between 30 and also 80. Okay, so, or maybe it's 20 and sorry, it's 25 and also 80. So, and you can see that the distribution is almost normal. Seems normal, it seems normal, but we have to check the normality if we really want to know. But you can see that most of the people are between 50 and 60 years old, and a few of them are older than 70 and also younger than 75 years old. Okay, so that's the distribution. It shows the distribution of the data, and it's a quantitative value between 40 and 50 and between 50 and 60. And the next thing is that the y, or the vertical axis, shows the frequency of the people that are within each category or within each bins. So let's make the histogram look better. For example, we can change the color of the histogram using the col command, and I use, I don't know, brown. Okay, let's see. So you can change the color, and also you can change the limits for the y-axis, right? So I can change it YLIM from 0 to 100. Okay, so that's for the YLIM, or I can use the shaded lines. Okay, so there is a command with the name of density. So for example, if you set the density to 10, you will have 10 lines. Okay, so 1 2, so in the, I think the most 1 2 3 4 5 10 lines. So it's used when you prefer to use a shaded line. You can use the density. If you, for example, increase the number of the density in the density argument, you will have more lines. Okay, or if you have, for example, 4, yes, for the biggest, for the largest bar, we will have 4 lines. Okay, so that's the density. Sometimes you prefer to have a shaded line. And the next thing is we can add a title. So we already have histogram of age, but that's a good title, so I don't change it. So R automatically generated the number of the breaks. We can change number of breaks using the breaks command. Okay, and then, for example, I don't know. Okay, so here you can have 3 number of the breaks. Let me remove it. I think the default value was better. I think it's automatically generated the optimum number of the breaks. So what we're gonna do is that, so this one was histogram of frequency. Okay, of frequency. We can create histogram of the relative frequency or percentage. Okay, so I'm going to create the histogram of the relative frequency. In that case, we add a new argument to this line of code that and we set the frequency FREQ to false. Okay, so it's not based on the frequency, and when you click on the run, so it creates the frequency, relative frequency. But why we can't see this? Because we set the while limit to between 0 and 100, and the values are relative frequency are less than 1, right? So I can change this while limit, or I can remove it. Okay, I can remove the while limit and then I can run it. So we will have the same shape for the frequency and relative frequency. So that's how you can have the relative frequency, and just notice that the values are very small. And for relative frequency, the total area of the relative frequency is equals to 1. And another important plot for the quantitative variable is Boxplot, which is made based on the 5-number summary. So we're gonna create Boxplot. Okay, so we're gonna create Boxplot from a quantitative variable. In that case is age. We already extracted it, right? So I'm going to create, so we use Boxplot command, and then very easy, I just put the name of the quantitative variable, which is age, right? So this is the Boxplot. It starts almost, the minimum is less than 30, the median is this value, the first quartile is less than 50, the second quartile is less than greater than 60, and the maximum value is between 70 and 80. So you can also see the exact value of this. You can use summary, right? Summary of age. So it gives you that the minimum is 29 and the median is 56. The first quartile is less than 50, 48. The third quartile is greater than 60, 61, and the maximum is 77. Okay, so the Boxplot shows the distribution and also the variation of the data. So we can also make this Boxplot horizontal if we add argument horizontal. I think we have to set this to true. Yes, so that's the horizontal Boxplot. Check the normality using the Boxplot too. So distribution is not perfectly normal. It's kind of skewed to the left, right? So here we have higher, so it's like this. You can also add the color and other things. So we will talk about the more details of the Boxplot. So we're gonna first create a very basic Boxplot. So add the color like red, and you can add the label for the x-axis. For example, the x-axis shows the age, right? So I'm gonna add xlab, which shows age of people, and then let's run this command. So you can create the Boxplot very easy. In the future labs, we will create several Boxplots that is used for comparison of the distribution. Finally, to compare two quantitative variables, so here we had just one quantitative variable, so now we're gonna compare two variables. So we can use a Scatterplot using the plot command to compare two quantitative variable. For example, I want to compare age, and which is a quantitative variable, and what else? I want to compare it with maximum heart rate. Okay, so maybe it makes sense. So how can I do that? So I'm gonna create a Scatterplot to compare two quantitative variable using the plot command. So plot, and then I have age, which is a known variable, but for the other one, which was maximum heart rate, it is not a variable, so I have to use we don't have it in here in the environment, right, in the workspace. So I use data, and then I use $sign to select the maximum heart rate, and then click run. So we will have a scatter plot. Okay, so it seems like there is a negative association between age and maximum heart rate. Okay, so as the age increases, the maximum heart rate decreases. We can make it nicer. For example, I can add a title to this, main command, and I can type age versus maximum heart rate. Okay, and the next thing is, let's see the result. So here is the title, and also xlab, because xlab is age but based on the year. Okay, so I'm gonna add the year inside of the parentheses, but don't forget this is a character, so we have to put it into the quotation. And we also have, I think it's better to change the ylab, is kind of ugly, so ylab to maximum heart rate. Okay, max heart rate. So let's see these changes first. So we have age, maximum heart rate. Important thing is that you can change the plotting character. Okay, so here we have, so we use pch command to change the plotting character. So we have pch, and we can set this to any character, okay, that we have. For example, I can use, I don't know, a star instead of the circle that here we have, right? And then when you click on run, it creates a star. And you can also use the letters. For example, I'm gonna use, I don't know, R. Okay, so it creates R. So you can use so many characters here, or you can use plus sign, or I think the star was better, or so anything that you prefer. Okay, so that's for plotting characters. And also you can change the size of it using the cex. You can change the size of it. If you, for example, select half, it means that it's half of the normal size. Okay, so I select cex equals to half, so the size is half of it, half of the normal value. And if you select 2, it's double. Okay, so that's cex, pch. I think half is better. And what else? You can change the color of it. For example, I'm gonna change this to orange color, and then click run. Alright, so when you're happy with your plot, you can always export your plots. Okay, so for example, here we have a plot. We're happy with this. You can click on export and then save it as an image or as a PDF. Okay, for example, as an image, you can save it, set the destination, that the output location, and then the image format PNG, JPEG, and then click save, and then it will be saved in the directory. Okay,